Effect of operating conditions. A compressor increases the gas pressure from point A level to point B level in the process of moving the gas from point A to point B. However, the gas is acted upon by its surrounding gas composition, molecular weight, and a specific heat, temperature, and pressure influence how a gas behaves. Also affecting compression is the system resistance, the pressure that the compressor must overcome, and the compressor compression ratio (CR). The compressor characteristic curve is a tool in representing how these parameters affect compressor operation. Considering the effect of gas temperature and pressure from the equation for GHP, it is evident that increases in gas inlet temperature, pressure, or compression ratio will increase the required GHP less necessary to compress the gas. Also, an increase in molecular weight or specific heat ratio will increase the horsepower requirement at constant temperature, pressure, and compression ratio. To demonstrate the equations for head and flow can be simplified by considering head versus flow. In so doing, the equations for head and flows can be reduced as follows. HP. The reduced coordinates define a performance map which does not vary with varying inlet conditions, has one surge limit point for a given rotational speed and compressor geometry, and permits or facilitates don't fuck around. For a given rotational speed and compressor geometry, the operational point can be defined by a line from the origin to the operating point.